Hi, I'm Mike Alperin, TIBCO Manufacturing Industry Consultant. We'd like to show you a new solution, one that easily scales to monitor large numbers of processes and parameters and produces automated alerts when anomalies are detected. It employs statistical process control methods and is an important quality control tool. This method is used to monitor, control, and improve any measured process. The focus is on reducing variability to improve quality. Control charts have played a vital role in the evolution and success of the manufacturing industry. The control chart was first developed in 1924 by Walter Shewart at Western Electric. It was initially used to improve the reliability and audio quality of the candlestick telephone. It was then used during World War II by the US Army, but was not adopted by US industry after the war. However, it was introduced to Japanese industry and became an important quality tool, helping Toyota, Sony, and others capture the global auto and electronics industries. This precipitated the 1980s US quality crisis, resulting in the reintroduction of statistical process control methods here. It was initially championed by Ford with their Quality is Job One initiative and Motorola with Six Sigma. Today, it is widely used across the globe and considered an essential tool in the mass production of manufactured goods. Its usage is growing in many other sectors as well, such as energy, healthcare, and telco. Our solution is quite comprehensive. Many types of standard process control charts, alerting rules, and charting options are supported. While rich in features, it is designed to be easy to configure for large numbers of parameters. The end user visualizes and interacts with all results in Spotfire dashboards. TIBCO Data Science is the underlying computation engine. Now I'd like to turn it over to Tomas, who will demo the solution and show you how it works.
Thanks, Mike. My name is Tomas Jurczyk and I am data scientist in TIBCO. So let us jump into showcase of solution.
Our solution consists of two components: front-end, end-user-facing dashboard application, and back-end, computation engine for continuous computations of results, monitoring, and alert triggering. Let us start showcase in front-end TIBCO Spotfire application. In our production, we are monitoring multiple parameters separately for product A and product B. In this upper left corner, we have unacknowledged alarms, which give us information where are the actual not yet handled problems, which at the same time means that these triggered the alarm notification. When we have a lot of parameters, we need some indication what should be our focus, and then these are actual burning problems, and these parameters are not behaving as under control process. Bottom charts are showing occurrence of alarms in recent history, including also already acknowledged alarms. In the whole application, we are looking at two types of violations. One is out of control, when sample point is outside the control limits of respective QC chart, is this upper visualization, and runs rules violations, which are pointing to systematical problems even if samples are not yet out of control, which means rules like several samples are on the same side of the center, or several samples in the row have increasing values. On the right, there is a summary of monitored parameters and simplified view when alarms took place. So for example, this first one, we can see that out of control as well as runs violations happened in the recent history. Application is interactive, so if I want to look at current alarm, I can click and parameter in question is marked in other visuals as well. The purpose of this page is to see overall situation at the factory and to help pick the parameter you want to investigate further. In our case, for example, we would like to investigate this one because it has the largest amount of recent alarms. Once we decide which parameter to analyze further, we will mark it here. At that point of time, the actual charts for that parameter are being computed. And we can go and inspect the results. On this page and other pages as well, we can see the detailed QC charts for chosen parameter. So here we can see X-bar chart and bottom is a variance chart. In our case is S chart. We can see the problem highlighted as well. Alarm is based on this sequence of points in our case. On the other pages we can look at the detailed info about this chart, so we can look at X-bar charts and look at the concrete points. We can look at variance chart. We can look at the runs test summary. So here we can see the actual info about runs violations, and we can see that our problematic situation is violating the rule 9 samples on the same side of the center. Now I will show you the largest advantage of this solution, which is comprehensiveness and flexibility. Because every parameter have its own definition of QC chart, which means different type of chart. You can show control warning limits, you can calculate runs rules and define what runs rules should be used or not use them at all for particular parameter. All of this is handled by one configuration table with the definitions how charts and alarms should be configured. Under the hood, there is a parameterized data function calling TIBCO Data Science Workbench. In other words, our backend computation engine. And this is calculating charts and out of control points based on values highlighted in this particular configuration file. So for example, if I change or highlight different line, for example here exponential weighted moving average, I will get different parameter visualized with different control limits and everything, and this is based on one row in this configuration file. With such an approach, you need to maintain only this configuration file, and everything else is handled automatically and visualized in one universal application like this. And now a bit details about Computation Engine. So computations are done using visual workflows and leveraging the same configuration file and the same function for computing out of specification points as in Spotfire application. There is a loop implemented which will run QC charts for all the parameters from configuration line. This will simplify the task of implementation of hundreds of QC charts one by one into maintaining one configuration file. Inside the loop, the results can be saved into database so they can be picked by dashboard application at any time, which was this summary page at the first page of the dashboard. These calculated results are in addition used also by monitoring and alerting component of TIBCO Data Science Workbench, which is this web application. And this component is checking on regular interval if there is any alert generated based on any of the QC charts. We have implemented in fact 2 loops for each product, 1 loop, and these tiles are saying something is wrong with the product A as well as with the product B because they are red. If we switch to the alarms, we can see we have 13 alerts for product A, 6 for product B. The last part we have not shown yet is the possibility to acknowledge the alarms once reviewed. So in our case we have found that for parameter 148 we have most probably false alarm. So we would go to monitoring and alerting component and acknowledge the alarms. We need to have permissions to acknowledge. Now we have less alarms in this table, and if we go to our Spotfire application again, to our summary page, and we click on refresh this monitoring alerting dashboard, this will pick the information we have done, and now we have only 7 alarms, and we can go further and start investigating other alerts which are still remaining. We have seen that presented solution enables the engineer to review the state of alerts, investigate any parameter interactively, and acknowledge the alarms.
Thanks for taking a few minutes to watch this demo. We hope you're as excited about the solution as we are. It features hierarchical monitoring and alerting based on quality control charts. The configuration table makes it easy to set up for large numbers of parameters. Many types of charts and rules are supported. Because the dashboards are in Spotfire and TIBCO Data Science is the underlying computation engine, the solution is easily modified and extended. To learn more, see the resource section for this demo. You can download this solution from the TIBCO Community Exchange.